All right, and we are now onto our second problem. Ring the bell. Bell curve. Gaussian functions. Anyways, working with linear actuator, measuring the current that's drawn. Company claims the current drawn during normal operation will be normally distributed with a, and this should say population mean, and we can probably need to put normally distributed population with a mean. Yeah, so population with a mean of blah, and a population standard deviation of blah. What's the probability of measuring temperature greater than 4 amps? So let's go ahead. Let's build this in. I'm going to just squeeze this right here. Let's go. So we have our, let's actually bring this up here. So we need the probability of measuring a temperature greater than 4 amps. So that means I need to integrate my PDF function from a value of z from my z function, which is going to be equal to, my x is 4, my mean is 5, and my sigma is 0.6. And when I integrate it from that z value to infinity, and it's thinking, that's the probability. Great. So there we go. Calculate an interval which contains 32% of the data. So now what we're going to do, integrate, and then we're going to say from minus x to x, and we need to solve what value of x, what interval will give me 0.32% of my data. So that is our z value. So now we need to do, let's go ahead and solve my z function. X is my unknown. My mu is going to be 5.6. Set this equal to this. So that'll be my upper bound, and this will be my lower bound. Beautiful. That's the interval. Fantastic. All right, so what's probably the measuring value between this and this? So we're going to take this lower value, which is going to be 3.8. Upper value, which is going to be equal to 6. And there it is. What about next problem? Measuring value less than 6.2. So we want to go from minus infinity to 6.2. There you go. And then finally, would measurement 7 be an outlier? So we need to do our mean, which is this, plus 3 times 0.6. So 6.8, 7 would be an outlier. What about 3.6? 3.2, 3.6 will not be an outlier because it has to be less than 3.2. That's it. Question 2, done. And we'll see you on the next problem. Thanks. Bye.